Hello, I'm Tom Luechtefeld, and today I'm going to be talking to you about BioBricks-OKG, an open knowledge graph for chemical safety. BioBricks-OKG is part of the Proto-OKN. We're providing all kinds of information about chemical properties, chemical classifications, chemical hazards, and this information is particularly useful for toxicologists. So data on its own isn't all that useful. We need to somehow apply it. So what we've been building at BioBricks-OKG on top of the data that we've been creating are different systems to access that data and to leverage that data for downstream use cases. What we've been building is an agentic system for toxicology. And without belaboring the point, I think many of us today are using agentic systems. It used to be that if you stopped working, the only time you lost was your own. But today you can spin off a task to do some deep research or write some code for you or generate an image or even make a reservation at your favorite restaurant. So these agentic tasks today are multiplying your output, but it's still the case today that most of what we do is most of these agentic tasks are driven by the user, by you. So when you stop working, typically most of these tasks are going to stop acting. Because these tasks actually provide economic value, particularly if we're thinking about tasks for toxicology, we want these tasks to be helping us to create safer chemicals. We want to find ways where they can act longer and longer and do more and more on our behalf. So what we're working towards is a persistent task system for toxicology. We want agents that can collect information, relay that information to you, the user, the green circle here, and even coordinate between users. So you can create a task to evaluate the chemical hazards for a chemical in your inventory, and then relay that information to your supervisor, to their manager, and really have a system that helps all users to create a safer world. So you can access that system today at toxindex.com, and I'm just going to do a few demos to bring home the point. You could ask, is perfluorooctanoic acid an endocrine disruptor? And we can kick off a agentic workflow, which is going to go out and access a lot of our data at BioBricks-OKG and do other tasks to try to answer that question. We can ask, is acrylamide a carcinogen? Is carbon tetrachloride hepatotoxic? And so on, just kicking off more and more tasks. And while those tasks are running, I can tell you a little bit more about the system. So BioBricks-OKG is a knowledge graph, and really the motivation for BioBricks-OKG was the existing data ecosystem for public health. Today, there are actually thousands of different databases for public health, and then if you include publications, there are literally millions of small documents that are informative for public health. To help with that problem, we built BioBricks.ai, which is a data registry for public health informatics. So you can go to BioBricks.ai today, and you can look at some of the bricks that we support. You can see some of them here. These are many of the common databases that people use to do informatics today. Just as a short demonstration of that system, I can show you if you were, say, managing a pharmaceutical company, a small pharmaceutical company, you might want to understand if your drug is going to cause, let's say, renal toxicity. So you might want to look up all of the molecular pathways related to renal toxicity. What ways might my drug create toxicity for the kidney? You might go to Wiki Pathways for that and ask your developer to pull the database and start analyzing it. If they were to do that, they might go to wikipathways.org, and they'd find the download button. Then they'd find many different options for accessing this data. And immediately you can see how this becomes a difficult problem. There are thousands of resources like this, and each of them have their own unique system for retrieving the data. BioBricks makes that a lot easier. If you go to BioBricks.ai, if you install BioBricks, you can install an entire database extremely quickly just by running something like BioBricks install Wiki Pathways. So you can see there that we access the entire database in under a minute, and then we can start analyzing that data, immediately. So here you can see us doing a query on that data. In this case, we're looking up different molecular pathways and the gene products involved in those pathways. So this works extremely quickly. You can also go ahead and use your favorite LLM to learn about different databases that are available. So here I just asked for good example databases for a demonstration. And you can see it pulled up something called MoleculeNet. MoleculeNet is an interesting database for benchmarking machine learning models that predict chemical properties. This is another example. You can go ahead and install MoleculeNet. Clipboard is in here. And that would just take you, less than a minute, so long as you have a relatively quick connection. You could download ToxRefDB. You could download SEVs. You could download CVTDB. You could download Tox21. You can download many, many different databases. You can go ahead and see the list for yourself at BioBricks.ai. So that was the motivation for us. Of course, every one of those small databases creates more analysis overhead. It's not enough that it's easy to get the data. Still, all these databases use different schemas. So they all use different ways of referring to the same chemicals, the same hazards, the same genes. And that creates a lot of overhead for creating systems that use that data for downstream goals. So we just did the demonstration. And that's why we built BioBricks-OKG, an open knowledge graph for these systems, where we've basically been stitching together many, many of these databases to make it easier to look things up. So we work BioBricks-OKG into this agentic system that I just showed you, and we're working in many other tools at the same time. One of the big arguments for that is that if you look at the chemical informatics space, you'll see literally hundreds of tools that do different things, like predicting metabolism for chemicals, predicting chemical hazards, predicting different ways to synthesize chemicals, classify chemicals, find different candidates. If you want to replace a chemical with a more effective chemical or a safer chemical, there are many, many different tools available for this today. We can think about BioBricks-OKG as yet another tool in that space. This is our schema, and this is definitely for more of a technical audience. But the basic idea here is that you have chemical entities, and you want to know about those chemical entities, what kinds of assays have been run on those entities, and what are the outcomes of those assays. So this is the basic schema. Once we have that schema, we can go ahead and retrieve data from our BioBricks-OKG. So BioBricks-OKG has hundreds of millions of chemical activities. You can see it on Frink today, where you can just run a simple query and get back chemical names, the endpoints, the measurements of those chemical names, and the actual values of those measurements. So you can see responses here and the units of those responses. Okay, so this gives us a tool to look up lots of information about our chemicals. It's really just one more tool in the hundreds of tools that exist for toxicology. And so we might ask, how does it maintain value? How does it actually become something useful within, let's say, an organization that needs to worry about their chemical inventory or, different toxicological aspects? So we've been building a system that leverages LLMs to exploit these tools. Basically, the system has many tools, has integrations with large language models. So a tool might be this database I just showed you, an open knowledge graph, and the LLM might be just Claude or ChatGPT or so on. And basically, these tools add a lot of value to just a plain vanilla query you might do on ChatGPT. So if you're trying to create like a toxicological report, rather than just going to your favorite LLM, you really should enable that LLM to have more power by integrating it with tools. Here you can see, if you were to ask an LLM, hey, what's the accumulation toxicity of a given chemical, it actually will perform relatively well. Here you can see along the x-axis, the actual LC50 is a measure of accumulation toxicity, the actual LC50 for a chemical, and along the y-axis, you can see what GPT-4o would predict for that LC50, the value that it would generate for that LC50 given the name of a chemical alone. But if you enable that LLM to do a retrieval step first, where it asks BioBricks-OKG, do you have information about Sesco mustard that can help inform my evaluation of the accumulation hazard of Sesco mustard? BioBricks-OKG can come back and say, yeah, the hazardous substance data bank can tell you that animals show loss of body weight, coughing, dyspnea, ataxia, and diarrhea prior to death. The CDC would tell you that Cisco mustard creates chest tightness, clear rhinorrhea, cough, and so on. And you can see that basically, if you go out and retrieve this information, that the performance of LLMs improves dramatically, with correlations going from 65% up to 90% and better in some cases. So basically, this is just a case of a LLM using a tool to perform toxicological tasks, in this case, chemical classification. So how can we scale that up a little bit? Let's see an actual application. If you go to predict.toxindex.com today, you can run a predictive model that predicts about 5,000 different chemical properties. And here you can see we're using it for, let's go ahead and use it for common phthalates. So DEHP is a plasticizer used in PVC piping. And there's some concern that DEHP is an endocrine disruptor. So alternative chemicals have been suggested as replacements to DEHP. You can see some of those alternatives here. If we want to run a predictive model that can tell us about these alternatives, we might use it to figure out which alternatives would be the best alternative for us. Here you can see I can generate a heat map, and I can ask our LLM to select properties that are relevant for endocrine disruption. On the columns, you can see DEHP on the far left, and it's our most problematic plasticizer here. And on the rows, you can see different assays that are predicted. If I go ahead and look up one of these assays, which is a data point in BioBricks-OKG, you can see that this is estrogen receptor beta coactivator binding inhibitor dose response confirmation. So there are many, many of these assays, and this one is relevant for evaluating endocrine disruption. So this is an example of a LLM using a predictive tool to help you reason about chemical toxicity. We can also use use additional tools to help us understand, create a better vocabulary for these assays. So we have simpler concepts rather than these thousands of different assays. We can use an LLM to say, is this assay effective for predicting agonism of the androgen receptor, let's say. And we can ask, which assays do I need to evaluate for activation of hepatic nuclear receptors or antagonism of the thyroid receptor. All of these concepts are available on are from AOP Wiki, which is a commonly used vocabulary for toxicologists. And you can see them all here. And these are more data points in BioBricks-OKG. Okay, so when you want to get an overall idea here of which of my chemicals is going to be more concerning for endocrine disruption, one very simple thing you can do is just add up the activities across these different concepts. And if you do that, you see that DHP comes back as far and away the most problematic plasticizer relative to the alternatives that have been proposed for it. And that's great. That's probably what we would like to see. We just saw how a large language model can use tools like predictive chemical classification tools to help us learn about our chemicals, help us explore alternatives. In that case, we were looking at plasticizers, but you can imagine many, many other use cases in many, many other domains. What if we combine many of these tools? Let a large language model use more than just a classification tool. Well, what we might think about is an orchestration system where an orchestrator takes a prompt, like is styrene a reproductive hazard? It parses that prompt, understands that the toxicologist is asking about styrene. It's asking about the hazard reproductive hazard. And it can think about what tools it should run to answer that question and generate, a report, a useful report for that question. You might run a metabolism tool looking at the metabolites of styrene. It could run chemical classification tools like we just saw. It might run that chemical classification tool not just on styrene, but on all the metabolites of styrene. And you can see exactly how multiple tools can synergize together in that case. The input to the metabolism tool is styrene. The output are metabolites. Those metabolites can then be used as an input to the QSAR tool. And we get outputs, which are chemical hazards or chemical properties predicted by the QSAR tool. We might then look up chemicals in an ADME tool. Just because the QSAR say that your given drug is likely to be a renal toxicant, what if it's immediately excreted and doesn't accumulate in the body? An LLM would want to use a tool that looks up absorption, distribution, metabolism, and excretion of your of styrene in some metabolites. We could also look up styrene in testing databases. These databases are encapsulated in BioBricks-OKG today, and it's part of our process of generating reports, toxicological reports. We can also just look up general publications, safety data sheets, regulatory guidance, and so on. Now our toxicological orchestrator here can take all of this information, reduce it, and respond to the user with a report outlining all of the information that's important for making a decision about whether or not styrene is a reproductive hazard. So that works today on toxindex.com. On Toxindex, you create an account, you create an environment, and then you enable that environment to have different resources. A resource might be like a list of the chemicals that you care about. You can then run workflows within that environment. And we actually did that at the start of this talk. So if we go back to Toxindex right now, we can ask, did any of these workflows complete? Let's refresh the page. We can see they completed quite quickly. We can take a look at carbon tetrachloride, and we can see a chemical toxicity assessment for carbon tetrachloride. We can do the same for acrylamide. Same kind of thing is coming back here. So rather than scrolling through this carefully, let's just take a look at, an output of this. The way this report works today, we call it the retrieval augmented prediction workflow, ToxRap, Toxindex wrap. And the input is an exposure and an outcome, like styrene and reproductive hazard. And the output is a structured report. This workflow uses academic search. It uses that chemical prediction tool that we demonstrated. It does knowledge graph retrieval on our BioBricks-OKG graph. It looks up hazards. It makes predictions about hazards. It does pathway lookup, metabolite lookup, and it creates 7 different sections. These sections give you an executive summary about this report being the DEHP report, about your exposure and the outcome that you're interested in. You can see it looks up chemical properties. It proposes toxicological mechanisms. It looks up the clinical evidence if it exists for those mechanisms. It does a risk assessment, and it provides a probability of risk. And then it considers things like risk factors. Are some people more susceptible to exposure to DHP than other people? And it anchors all that information back to our database and to references to publications. So we actually just looked at those results, but these are exactly the results that come back from that analysis. So you can actually run these yourself today. The production version of Toxindex has a very early version of Toxindex wrap running, and we're quickly iterating on that, but certainly would like your feedback if you want to play with it. So what might you use these tools for? Well, we already talked about metabolism, QSAR, testing, ADME. You might look up similar chemicals or do a safety data sheet lookup. You might look up properties of a chemical. One major use case is doing property inference, particularly for chemical hazards. But what are the higher level use cases that we're working towards? One is hazard surveillance. If you're evaluating whether or not a chemical is hazardous, you might ask, is it hazardous today based on the known information today? And has that changed in the last month? So you actually might want to rerun these workflows periodically and ask, is anything changing? Are there new potential for hazards in my chemical inventory? You might want to survey all of the regulatory compliance out there. This is another workflow that we're implementing that allows you to monitor global regulatory changes for a given chemical portfolio. And you might want a workflow that can suggest alternatives. Let's say your chemical comes back as potentially hazardous for a given endpoint. You might ask, okay, is there an alternative that I could use? Or maybe it shows up in a new regulatory list. You might ask, what are the proposed alternatives for the chemical in my pipeline? Okay, so thank you very much. We went over today BioBricks.ai, a data registry where you can, install a tool and quickly access hundreds of different public health databases. Went over toxindex.com, which has agentic workflows for toxicology, particularly right now, a workflow that generates a report, evaluating many different aspects of chemical hazards. We saw predict.toxindex.com, which is a tool that runs predictions on thousands of different properties for chemicals and uses a large language model to help the user understand those predictions. You can use predict.toxindex.com to compare many chemicals and see how predictions vary across different chemicals. And we, of course, saw frink.eps.rensi.org, the main fabric for Proto-OKN, and where BioBricks-OKG lives today. This is a query application that allows you to look up information from BioBricks-OKG, chemical safety information, or look up information from any of the other graphs that are supported by the Proto-OKN. So thank you very much. If you're interested in toxicology, if you're interested in running toxicological workflows, please contact me. I'm Tom Luechtefeld at insilica.co. Thank you.